let's differentiate this function. And after we obtain dy dx, we're going to substitute x is equal to pi while y is equal to 1 to the final result. To solve this problem, let's apply implicit differentiation. In the front of sine, we have xy, and we're going to differentiate this using product rule. However, differentiating the entire function will be chain rule, while to differentiate this, we are going to apply product rule. But the entire function is implicit differentiation. This is 2 pi. It got neither x nor y. Step number 1. We're going to differentiate xy. We're going to keep x constant and differentiate y is going to be 1. However, we're going to multiply that with dy over dx according to the rule of implicit differentiation. Next, according to product rule, we have a plus. Next, we're going to keep y constant, and when we differentiate x, it's going to be 1. We are done with xy. Next, let's differentiate sine, and we're going to get cos. Next, we're going to recopy back x and y according to chain rule. Now we are done with this and have obtained the derivative. Next, this is plus, hence I'm going to have plus here. Consider 2x multiplied by y squared. I'm going to keep 2x constant. If I differentiate y squared, I'm going to have 2y. Because I differentiated y, I'll multiply it with dy dx according to the rule of implicit differentiation. Next, I will put a plus. Next, I will keep y squared constant. When I differentiate 2x, I will get 2. The differentiation of this gave us this. Next, let's differentiate 2 pi. Here, there is neither x nor y. Hence, when you differentiate 2 pi, it is 0. Next, we open up the brackets. Next, this will multiply this. Likewise, this will equally multiply this by distribution. This multiply by this, you will get this. Next, y multiply by this, and you're going to get this. And everything here remains the same. Next, this without dy dx and this without dy dx will move over to the other side of the equal sign. Next, factorize dy dx out. Now that we have factorized dy dx, next make dy dx the subject. Hence, this is our dy dx. Next, we're going to substitute for x is equal to pi and y is equal to 1 into our dy dx. Next, now that we have obtained our dy dx, wherever I see x, I'm going to put pi, and wherever I see y, I'm going to put 1. Next, pi in front of a trigonometric function is equal to 180. Hence, cos pi is the same thing as cos 180, and cos 180 is equal to minus 1. However, pi outside a trigonometric function is not equal to 180, it remains your usual 22/7 or 3.142. Hence, this is equal to -1 and this is equal to -1. Next, let's simplify our results. -2 plus 1 is -1, and minus pi plus 4 pi is 3 pi, and this is our dy dx. Next, alternatively, let's use the shortcut method. First, let's consider this. However, my concentration now will be at x. Let's differentiate x. We're going to get 1. However, I'm going to ignore y. Next, we're going to differentiate sine, and we're going to get cos. Next, I will recopy back the x and y in front of the sine. Now I'm done with this. Next, I will put this plus. Next, in this function, I will differentiate x and I will have 1. However, I will ignore 2y squared. Because of the presence of this negative, everything here will be in brackets. If you differentiate 2 pi is 0 because it contains neither x nor y. At the denominator, I'm going to differentiate y and it's going to be 1. However, I will ignore x this time around. Next, differentiate sine and I'm going to get cos. And I will recopy back xy in front of the sine. I'm done with this. Next, I will include this plus. Next, I will differentiate y squared and I'm going to get 2y. However, I will ignore the 2x. Next, we simplify our result. Next, wherever I see x, I will put pi, and wherever I see y, I will put 1, respecting the condition from the given question. Next, cos 180 is -1 and cos 180 is -1. Because pi in front of a trigonometric function is equal to 180. Solving carefully, we obtained -1 divide 3 pi. From the options, our answer is A. This is calculus. I will see you in the next video.